talk more in detail about Kubernetes plugins, CNI. So we have both introduced ourselves before, so in the interest of time, we will not repeat. So I'll just kick off the session with why containers and what are we doing in developing the ecosystem around containers and in Edge in general. So I don't know, the slides are moving themselves. I'm sure everyone has seen some version of this slide before, right? Everybody is talking about 5G and 5G and next generation of network and how much data it will generate, how much bandwidth it will generate. Well, so here the data is like the user data is 1.5 gigabit per day, whereas data from machines or drones would be 18 terabytes per day, and from automated cars or connected cars, as industry likes to call it, like automated cars are a little bit farther out in the horizon, but connected cars are more immediate. For them, it's 4 terabyte per day. And then AR, VR, media type of applications, 3 terabyte per minute. But what I want to impress here is, this is not a deterministic data by any means. These applications are going to come up and come down, tear up and tear down, so the network has to be very scalable and agile. And I know that service providers are working on 5G, but immediately Edge is something that is more immediate, and that's happening now. So anybody heard of CDN, for example, right? We know that, right? So that's in a way Edge application that the industry is already using. So why Edge? This slide just has some data or some perspective on what an application would gain in putting the compute close to the user, right? It's the limitation by the laws of physics, right? How much time the data would take to travel through the network pipe. So of course, if it is on the device, it's 1 millisecond latency. On-premise or edge, less than 5 milliseconds. And on the network edge, or what we call it, access, 10 to 40 millisecond. And as you go further into the network, it keeps increasing, right? So if you're talking about things like cloud gaming, automated driving, autonomous driving, remote VR, healthcare, things like that, you need the compute close to you. And that's why Edge is important. Now, coming back to the scalability and agility of the network or of the network services, it has to be small footprint, it has to be scalable and agile. So you need to be able to bring the services up as needed and tear them down as fast as possible, right? So the industry has been talking about VNFs for a while now, but containers is the next big thing. How many people have gone to KubeCon, for example? Yeah, there we go. So maybe you can say how the KubeCon has grown in the past 3 years or so. Okay. In fact, I think in Seattle it was like 12,000 or something, right? 8,000? Okay, yeah. So in EMEA it's going to be more, okay, which is Seattle. So, well, this is Probably everybody knows, right, who's behind some of the most popular projects, right? Kubernetes, right? Google. So this I took from cloud.google.com. Right? So in the cloud service provider world, it's like common knowledge, like containers are being used. It's only in the comm service provider side of the house that they're slow to adopt. Right? So as you can see, they're saying that if in Google, for Gmail and YouTube search, everything runs on Google containers. And every week, they start over 2 billion containers, right? So that's a tremendous data point. Now the other data point from AT&T, comm service provider, right? So they say that they're going to make their cloud 100% container based. So this is from SDX Central. From their own site, I tried to find, on the AT&T site what they're saying. On their site, they still say that by 2020 they're going to virtualize their network by 75%, and containers are going to be a huge part of it. So I couldn't find this, but apparently someone from AT&T talked to SDX Central and said that they were working with SKT, and that's what their number is. But regardless, containers are important to the industry, and they're not going anywhere. So here's, everybody's talking about containers, and containers in the biggest project in the container space is Kubernetes, right? So I was looking at data on how to separate hype from reality. So I found this article, sciencelogic.com. I have the links there, so you can read the article. Once I share the slides, you'll be able to click on it. So what they say is why Kubernetes, right? So it's basically a container management system. It's not, it does not have any legacy baggage, right? So its focus is not blurred by protectionist agenda. How many people are familiar with open source projects spurned by individual companies because they want to have their open source project win, right? I mean, that's a common thing that happens in open source. But that's not the case with Kubernetes. It's not locked in to any particular vendor or any particular cloud system, right? So that's one of the reasons why it is succeeding and getting the wide adoption. So it was born out of need to provide automation and orchestration. It was incubated at Google for decades, right? So it already had a level of maturity when it came into open source. And it simplifies managing complex container-based applications, whether running them locally, in public, or both, right? And it supports different models, virtualization models, including OpenStack, and like I mentioned, public and private cloud. So that's why, according to this article, Kubernetes is there to stay. It's going to deliver what it needs. So how does this figure into what we do? How many how many of you know that Intel is one of the biggest contributors in, say, for example, Linux kernel? Okay, yeah. So I found out about this recently, right? So in addition, you see all of these projects here that we are contributing to. And of course, containers and Kubernetes is a big part of it. And now we are going big into the Edge framework as well. And this protocol stack, combined protocol stack, which combines elements from media, from IoT, from virtualization, and also wireless domain. This is what, this particular diagram shows how, the different projects that we work on in those different verticals, different workloads, how we are converging them into a single stack which can be used into the Edge ecosystem. And of course, it leverages our hardware product family. So particularly for Edge, how many have heard of the term openness or the project openness? I mentioned it a while ago. Stands for Open Network Edge Services Software. We announced it at MWC. I think it was, now it's last month because we're in April now. Or it was in February, I forget when MWC. Yes, February last week was MWC. So the first code drop for this software would be June end. So what it is basically a services framework, a network services framework. So it can be used for different use cases, UCP, vRAN, NGCO, and it provides services for authentication, telemetry, service registry, multi-tenancy, and cloud and application framework. And then it also talks to controller software back at the data center. So then it supports things like application discovery, control, policy management, etc. via standardized APIs, and supports XCMake API as well. So for those who are familiar with NEV SDK, which was set of libraries that has been available for some time. It was not really open source, but was available on request. Openness is basically based on that, and it also supports public and private cloud. It has hooks and APIs to work with that. It is based on Open vSwitch and FIDO data plane. And like I said, it works with the XCMake APIs. So what do we do with this? What does the industry looking for, and what are we looking for? For the Edge and 5G, it's clear that 5G is not just the bigger pipe with the higher bandwidth and lower latency. It's basically a platform for innovation, right? So from Intel, we are looking for developers. We want to work with you guys outside of Intel, and we want to encourage those innovative ideas that come from you, right? Because we from Intel are good at delivering cutting edge technology at regular cadence, right? But then we can't look for the applications of this, or we can't imagine where this technology could be used. For that, we need you guys, and we want to help you do that. So if you have an idea, we are looking for those ideas via devmesh.intel.com. Here's an example innovator. Frederick, who just talked before us, is also an Intel innovator. Andre Renard, who's featured here, he works at Dunlop Institute of Astronomy and Astrophysics. He's used DPDK and Intel-based acceleration quite innovatively in his radio telescope. this radio telescope gets terabytes of data per second with 360-degree views of the cosmos. And this telescope has actually garnered a little bit of press already. So while your project might not be as ambitious, but it can be a different use case of an existing technology, or combining different use cases like what Frederick is doing, or there's another innovator that we have. He has combined tungsten fabric with OV switch, and they have services on top of that. So it can be in any range. So we are looking for the next superstars among you. So please log on to this website, give us the ideas, and there are perks if you get selected in this. We call something like early innovation project. So in Q3, Q4 we'll be encouraging a lot more of them. So that's why we are asking for you to submit. And some of the qualifying projects can also be done via Linux Foundation Community Bridge. How many people were there at the Open Source Leadership Summit? Okay, a few people. Yeah, so they announced this community bridge. So basically, the whole idea behind this is to encourage open source projects to thrive. So we would also be doing that, and I'm working with Linux Foundation to make that happen, to have our early innovation project come through the Linux Foundation Community Bridge. So with that, I will stop for any questions before I hand over the floor to MJ. Okay, you can find me later.
Give a round of applause, please. For all the work that was doing. Okay. I am the one who is standing between you and the dinner, so I will make it brief. So it's very simple, right? I think we talked briefly about the introduction in the morning session, right? So cloud is coming from certain goals and objectives, and then DPDK is coming with its own objectives and goals. Interestingly, they are completely opposite to each other in a way, right? So that's where we want to see what both the camps are doing to make sure you as a customer is going to get the best of both. So in this, we are going to focus on more what DPDK plugins are going into container to make the cloud infrastructure more closed loop, meaning intelligent and aware of what's happening and things like that, right? So how many of you are familiar with Kata container, the name Kata container? Okay, very good number. So if you see this picture, right, container versus VM, in the earlier days, we used to think, okay, is it going to be a single point for failure in terms of containers? And then people brushed aside, but I think that concern is still there. Security, if you say VM may be winning, container may be still, there, because every, the namespace is different, but still all the applications are sharing same infrastructure, not that much isolation, right? So Kata container comes to that rescue. If you see on the right side, right, on the left side is the problem statement, security, what we talked about. On the right side, if you see thin VMs. So it has the benefit of both containers and VM. When I say thin VM, it doesn't have the whole system what the regular PC, it is a very stripped down version that it has. That's why it is lightweight. But it provides that isolation what container is lacking. So you get the best of both in terms of VM as well as container with Kata. So we're talking about two different things, right? One is DPDK taking the juice out of the platform, and then container coming from elasticity and ease of scalability, how they are merging. And then we are also talking about VM and container. There is a security aspect, and that's where Kata container comes into, right? So now there may be people here who are well versed, because the previous meeting I saw, and then a lot of questions. Looks like what I'm gathering from that is you are all experts in the cloud and containers point of view. So for you, some of the terminologies may come very naturally. Similarly, the DPDK, there will be experts in DPDK. For them, certain terms and terminologies will come naturally. So we will talk about how we can, make for each one of you the other field that is new to you to make ease. We'll do a analogy or a simile comparison from known to unknown, very easy for you to go with. But if you look at this picture, right, this is the Kubernetes cluster. You can see various terminologies, but nothing to scare off. If you are DPDK familiar, in the next two files we will compare some commonalities, right? So to just go over, you see pods, and then you see nodes, kubelet, and then API server, HC storage, controller manager, scheduler, right? None of these words we heard in DPDK, correct? But then is there something similar functionality that DPDK also has? If that's the case, what is the terminology mapping? That way, when I look at it, if I'm familiar with DPDK, I can connect dots and then I can understand the functionality, right? So that's what we are going to do, right? Next one. But just to go over the terminologies, what we saw, container, we are all familiar with it, right? It's isolation boundary. Kubernetes, it's a deployment case. Pod is the basic unit of deployment, and then node is the one which can have multiple pods, and then master and minion, manager and individual contributors. You can think of that way, right? Master is the manager, minion is the real worker who contributes, right? And then API server, scheduler, controller manager, container runtime, kubelet, kubeproxy. So what are these words, and then how does that map for DPDK, right? If you can, and this is the block diagram what you see here. SD, you can see that on the left side, that is more like a name pair and all stored there. And API server is what abstracts the user from the details of the network or the core topology, right? They don't need to know where each service is running. They just need to know the job has to be getting done, right? Right. So the way I compare in this picture is, right, how many of you have managers, right? How many of you have managers? All of you are managers, or you have managers, right? We have managers, and your manager as team, right? You and me working for the manager, but let's say somebody else is coming and asking your manager, give me some resource. They will use the word resource normally, I've seen that. And then they will not, the managers normally will not give the names of the individuals who normally does the work, but they will say, okay, I will assign somebody. The reason for that abstraction is thereby outside team need not specifically ask any particular resource, right? That's what the manager's job is anyway, right? Similar concept here, API server is more like that proxy which does the service without giving the details about the place where the things get executed, right? So microcosm and macrocosm commonality, right? So the words, how many of you familiar about the comparison? People talk about the universe comparing to what the individuals. If you consider you and me as microcosm and the universe as macrocosm, there are some commonality, right? Can you tell what are the commonalities? People talk about 5 natural forces, right? What are the 5 natural forces? Earth? 4 only, yeah? Okay. I thought earth, water, air, space, and then fire. Forces, okay. So there are 5 natural things which is, goes, okay. Earth, water, and then air, and then space, and then fire, right? So if you translate it to the microcosm, what we eat is from whatever is grown in the earth. So that's the earth. What we drink, water, right? Our body is also like 25 to 75. Same as the earth is like 75% water and 25%. So similar comparison if you talk about, right? Here on the left side I have container technology, on the right side I have DPD technology, terminologies, more or less similar functionalities what each one do. So if you are familiar with DPDK control plane master core, right? Because you have multiple cores, but you always leave the master code 0 for Linux work, right? And that's what in the container technology talk about master container. Master container pretty much schedules the tasks into the real worker threads in a way, right? And the pod, what we talk about in container, in DPDK terminologies, that's a L core. We talk about L core, right? If you have hyperthreading, you enable the hyperthreading, and there are 2 L cores, right? Threads, that's a pod. And the node is a physical core, because in physical core, you can have multiple L core. Similar concept, in a node, you can have multiple pods, right? And then microservice is the real L thread or P thread, depending on in DPDK whether you're using cooperative threading or POSIX threading. And then minion is the worker core. I'm just comparing that by, for me it was very difficult to understand to start with container technology, terminologies. So this helped me for putting lookup. So we have something called load balancer in DPDK, because load balancer pretty much abstracts where the service is really getting executed, right? It does the hashing and then it finally schedules the task at the end worker thread. Same thing the API server does in the container technology, right? And then scheduler is exactly the same thing, what we talk about on DPDK, P thread to L core mapping, core pinning, all of that. And then in container technology, we talk about controller manager. In DPDK, what do you refer that? You refer the EAL for exactly that, right? EAL does the configuration, initialization, and that's what controller manager does. And HCD is the database which in DPDK we talk about hashing and 5-tuple solving for worker code. And if you talk about kubelet, that's what runs in the minions, right? That's a DPDK dispatcher. Normally we do not have DPDK dispatcher, DPDK poll mode, but then there are cases where there are dispatchers like in pipeline mode, which goes and dispatches things. So kubelet, you can think of that. So that comparison somehow puts me back into this to understand, okay, I see pod is the L core, okay, I see node is the I core, well, API server is the, the load balancer type of thing, controlling manager is my EIL. So I can draw some simile, right, even though it may not be the exact 100%. So we talked about, I think many of these we touched upon in the morning session, right? What is that the container lacks in a way? It pretty much uses the same infrastructure, networking point of view for control, management, and data plane. And that sometimes is not, acceptable for high-performant data plane-centric applications. For example, you may want to have multiple networks, one network carrying only the data plane node, and you want to possibly control the policies and things like that on that network, whereas cloud infrastructure controls the policies on the control plane, and that may be fine, but for data plane you want to do that. So that's why we need to have something called Multus CNI. CNI is the container network interface, and that is the agent. You can think of it as an agent, which says, okay, I'm going to enable multiple network, but this is something, my own domain, I'm going to do the policy management, everything. And then that agent will possibly have more children, and that will be different types. For example, one can be a kernel SRIOV CNI, right? SRIO is network segregation, right? You have a high-performance network, and you want to give direct access to a portion of that physical network to your container. You don't want to go through multiple abstractions to get to the network hardware. In that case, you can do the SRIOV, but still you want to have all the kernel's benefits of features. You do not want to go to DPDK SRIOV, and that is a CNI. So Multus understand that, and it gives control. And there are configuration and structure where, like, you have the node specification. From there you can say, I have this type of this networks. You can say I have a regular flannel, I have my SRIOV kernel CNI. So then this Multus CNI will go and give control to each one, and that will go through configuration files to instantiate those CNIs, right? So that is for network enhancement. We have plugins. I just showed two. There are many more. In fact, Untitled vhost, CNI plugins. Similarly, SRIOV, DPDK, CNI plugins. I have not listed them. Those are all part of that. Okay. So are you all on same page? The cloud, as Google they defined, the container had only one network coming in, and now this plugin lets you have control plane, management plane, and then data plane separate. Now, the moment we do that, you can also assign CPUs differently. For example, you can say, I want to have a list of CPUs for only data plane operation, which means it will be very much not shared. And then you can say, I have another list of CPUs. This is for my control plane applications. Then I have this other set of list of CPUs, which is for my shared. I can share it. It is not for like my data plane, but I can share it. Maybe you will use it for management application, for example, right? So those things open up the moment you do this type of network disaggregation, right? So then the node feature discovery comes. This is where we talked about in the morning. The trajectory showed Intel releasing, or any company, right? For example, releasing CPUs one after another, with each one having incremental beneficial features. But let's say you have a workload which you know for sure will run better on your particular instantiation. Then how do you give that benefit to that application to run on that? Which means now you need to be closed loop system. You should be able to go and fathom the network, the cores, and find out what capability is where, and then get that information, store somewhere, and then scheduler when it comes has to look at that, and that's what the node discovery mechanism and then the node label mechanism works with the other. So what the node feature discovery is, it's not a hot plug mechanism. It is a one-time mechanism. One time you instantiate a pod, and then that pod goes and executes and then probes. It probes what are the features that are there in that machine, right? Whether it is vector processing or scalar processing, what level of virtualization is there, and what version numbers, various things it takes, and then it puts in a label, a database, and then specify that. And then later when a scheduler comes, it can go and look at, okay, I'm looking for this, it can query, and then it can schedule task accordingly, right? That's the node feature discovery. If it was not there, what happens? If that was, right now it is not there, these are all coming with the DPDK container add-on. Without that, now you have all citizens equal. Now you are able to have first class citizens, second class, third class, right? So like that you can have color the various cores. Node feature discovery does that. And CPU core manager, then this is where the controlling part comes, right? Node feature is more like going and peeking and probing and gathering information, and CPU core manager is the one which is going to use that to say, okay, that's what I want to run this is what I want to run, I want to pin it, I want to isolate it, I want the DPDK, I want the Linux scheduler not to bother me, and all those things can be done with the CPU core manager. So you are pretty much bringing all the platform awareness, we call it EPA, enhanced platform awareness. If you go on Google and search Intel enhanced platform awareness, Intel EPA, you will find a whole bunch of things. For example, right, we are talking about now virtualization, right? So you are, and then we are talking about east-west traffic, we are talking about micro services, we are talking about service sharing. What it implies is possibly in one host you are running multiple VMs. Now the cache is shared among all of them. Last level cache at least are shared among all of them. So depending on how you position your tasks into the cores, the cache will be getting polluted or not polluted. We call it noisy neighbor. And there are certain CPUs, beyond certain CPUs, we have something called RDT. You may want to write this down. RDT, when you go on Google, you will find information on this. Resource Director Technology. RDT stands for Resource Director Technology. So let's say you want to run a latency sensitive application, and you want the cache to be not polluted, you want everything to be hit, you don't want something else to come and pollute the cache. then you want to run on your processor which can let you do policy decisions on cache lines sticking. You can lock the cache lines, you can lock the memory lines, so things like that, right? We call it cache QoS, platform QoS. So you can search these words, Intel cache QoS, right, RDT. So then this will run, and then you are going to have the high performance, demanding, low latency application run peacefully because you understood from node discovery that type of processor where it is, and then you used the other CPU manager plugin which can go and execute in that. If it was not there, what happens? Normally in cloud, you ration the CPU cycles with, right? Now you ration it, and so what happens? So by default, we may have a quota system, right? Now one of them suddenly sucks up a lot of bandwidth, lot of cycles, then possibly you will eject that, and then you will try to schedule somewhere else. Now you are adding more and more overhead to that, right? Whereas if you understand its requirement and you properly schedule, possibly you are going to do more good for it, right? So this is what the picture, right? If you see the, how do you say that, etcdxc? If you see that, node 1, if you see there's a red tag and blue tag, node 2 only red tag, node 3. So that's the capabilities. So capabilities you are able to record because you did the node discovery. And then schedule is able to use that information and then do accordingly, right? If you see here, node 1, right? Node 1 you have, so if you see here, okay, so the capability, node 3, yeah, so we show that the tags here, the same tags, node 1 has a different tags, node 3 has less number of tags, right? And then the discovery pod is running in all, the green one. That is run only once to go and probe it. So if you see here, the top, the Catalyte 2960 switch, that is the switch which is connecting the regular cloud infrastructure. If you see, every node has only one interconnect going. But now because of the add-on, you are able to now connect to the SRIO plugin. SRIO plugin is a child of the Multus plugin. In fact, Multus plugin has another child which is a default network called Flannel plugin. Well, that's what your VXLAN and overlay will go through. And you are able to see this part is running DPDK, and it has a CPU core manager which can schedule properly. Are you seeing the difference between the left and right? The left one is manager, the right one is minion, right? So if you see the components like Kube scheduler, Kube controller manager, Kube API server, they are only in the manager, whereas the minion will have kubelet and kube proxy. So if you see kubelet, that is more like, in the DPDK terminology is what we said. Kubelet is more like the distributor, so dispatcher. And kube proxy is more like, what is that? What is a similar comparison to kube proxy? The load balancer core, right, which abstracts where things are getting executed. So if you, how many of you have done this virtual box, right? When you virtual box, VM player, right? So when you start it, it will have its own by default a network. That's what Docker also has. Docker 0. That's a default network, but I think that's getting phased out. What now everybody is pretty much standardizing on is the CNI. CNI is the next level, which is going to have the basic overlay, the Flannel and Calico type of things. And now on top of that, we have the Multus to expand more than one. Okay. So here are the reasons why you need multiple network interfaces. Redundancy is one. Segregating control from data plane traffic. I think we talked about in the morning the benefit of DPDK, right? Multiple stacks can be there. So that's the reason you can also have multiple interface. Network slicing, one of the examples is SRIOV. So you can have SRIOV by having separate data plane interfaces. If you don't have, if you have both control plane and data plane has to go through the same, then SRIOV doesn't fit natively there, right? So slicing offers container direct access to high performance NIC hardware. So these are the reasons why, and this is how it all fits in. If you see here, the CNI is a one interface, but then the Multus comes and then it can have multiple children, and the flannel plugin is there by default, the regular one without the control plane. And if you see the next SRIOV plugin, there are two types. Are you able to see one behind another SRIOV plugins? What's the difference between the north and south? Both says SRIOV plugin, right? What's the difference between them? Here. Both are saying SRIOV plugin, but what's the difference between those two? Huh? One is saying DPDK, correct? Another one is not saying DPDK. The other one not saying DPDK is the kernel SRIOV. So power on, when you power on, what comes with the NIC PF, physical function, then when you do virtual function enable, then it becomes kernel based, because kernel owns the VF by default, and if you want to stay with that, you can stay with that. That is the kernel SRIOV. But if you want a DPDK based, you need to go and remove that kernel based, and then you have to force your DPDK on top of that. Okay. So that shows that picture, and then pretty much this is the regular existing EN1 is the regular existing one network in the container. We went through this. This is the flow chart. So this is the by default you have only ETH0, but now the moment you add more networks, you are able to have many networks. This shows DPDK, SRIOV. This shows regular SRIOV. I think we are done. Pretty much this is all going to go in details. We talked about the first class, second class citizen. That's what the node labels, node discovery.